Okay guys, welcome to week 3 of Econometrics. What I'm going to do today is walk us through another practice example using our Jupyter notebooks. We're going to look at my code along with, on the right hand side of the screen, the Python assignment. I'm going to talk us through that. This is again just a practice one for you guys, although I will be assigning you your one and only Python or Jupyter notebook assignment that is outside of data camp. So you can look for that this week in the week 3 folder as well. But for right now, what we're going to do is just continue practicing, learning a few more, tips and tricks, working with some more data, learning a few new steps that are necessary as we work with this data, and we're going to go from there. So with that, if we want to look over here at Python assignment number 2, I'll just talk through the brief steps. A lot of them match from last week. At the beginning you'll see, and then we build on that. Okay, so for assignment number 2, or the second one that we're working through together, we're going to create a library. We're going to import stock data for 3 different stocks. I provided them to you, but you know how to do that now as well through Yahoo Finance. We're going to drop unnecessary columns from the data. We're going to add a column for each company name. We're going to stack the files. In other words, we're going to concatenate them. We're then going to convert text dates to date formats, calculate returns, drop missing observations. We're then going to learn how to calculate standard deviations of stocks for each stock and each year. We're going to learn how to merge data sets together. So instead of stacking them on top of each other, merging them together by some common variable or variables in each file. We're going to learn how to filter data. So filtering out, in this case, negative returns. Or in other words, we're going to retain stocks that have positive or 0 returns. We're going to confirm that our new file has no negative returns. And then finally, we're going to be sorting the stocks by ticker and return and calculating average stock returns, not all descriptives, but just the average stock returns for each company. And again, this is not graded, so you can ignore the last 2 steps. You don't have to save your code or discuss this next class. So with that, let's kind of jump into my code over here on the left. And I already have it written out. We'll go through it again step by step as we did last time. I'll kind of talk through why we're doing the different things that we're doing. But again, at the top, we're going to import pandas as PD and NumPy as NP. And this here is just some markdown or text kind of letting you guys know what each step is trying to accomplish. So we're going to import files, drop unnecessary columns, and add a column name. So let's just take this first line of code. We're going to import the file I have for Apple. And really quickly we can look here. This is what the file looks like. I have an Apple, a Disney, Microsoft, your assignment that's open on the right, and this code here. So I'll be uploading all of these to D2L. Okay, so let's get started. We can go ahead and import the 2 libraries that we're going to be using, pandas and NumPy. And what we have here is some markdown or just some text letting us know what I'm trying to accomplish in the next little bit of code. Importing the files, dropping the unnecessary columns, adding a company name. But before we actually do that, which is this larger box down here, I just want to open one file and I want to see what is in that file. Okay, so when we download the data from Yahoo Finance, last week I gave us some cleaned data. This is what the data actually looks like when you directly download it. So we have date, the opening price, the high price throughout the month, the low price, the closing price, adjusted close, and volume. So I can tell you right now what I've asked for over here in the assignment only involves the return. So we're calculating returns. So you're going to need the price, and that's really all you're going to need of all of these. So we're going to use the adjusted close. So we can get rid of this. We know what's in the file. We'll just come to this one down here. What we're going to do, we're going to open Apple. And what we do here, what we're saying is to keep only those columns titled date and adjusted close, or ADJ close, which is what they were called. If we were to only keep a single column, we could just go like that in single quotes. But because we want to keep multiple columns, we need to have a list of those column names. That's why we have double brackets. Okay, so we have now dropped the unnecessary columns, or I guess more specifically, we have kept the columns that we want, then by default dropping those that we're not using. And we're going to make a new column name, because as you recall, there is no indicator. There was a date, and there was a bunch of variables related to price, but nowhere in there did it tell us that it was Apple. Nowhere in there did it tell us what company this was referring to. So we're going to say take our AAPL file and add a variable called the company, and we're going to set it equal to AAPL. And that's really all we're doing. We're then going to repeat this for Disney, and we're going to repeat this for Microsoft. So if we run this cell, we've taken care of that. We have 3 files, Apple, I'll show you what they look like individually, AAPL. Okay, we have company name, which we've added, adjusted close and date, and Disney, there's that file as well. And if you didn't want to just type out Diz, you just wanted to see the top few observations, you can add the dot head. But that's what those files look like. We're now going to stack these files on top of each other, exactly what we did last time. We're going to concatenate the files. And in this case, what we're going to do is, instead of just concatenating 2 or stacking 2 files on top of each other, we're going to stack 3. And this works perfectly well. There's nothing really to be worried about in terms of them working, because all 3 have the exact same columns. They have a date, an adjusted close, and a company. So let's go ahead and do that. And when I run this, this is probably a new bit of code that you haven't seen, dot sample. It behaves the exact same way as head does and as tail does. The only difference is sample is going to give us a random sample of however many observations we put in here. So we'll get random ones throughout the whole data set. And there you go. So with this random sample, it's showing us, first one's an observation for Disney, Microsoft, Apple, Microsoft, and so on. And if we were to run this again, it'd give us a different sample of 10. And that will just keep on going down. So I've run this next bit of code because what I want to know is, if we look over here, we've stacked them, convert text dates to date formats. We did this last time. And this is kind of just a reminder of how you can tell. So right now it doesn't know these are actually dates. It just views them as text the same way it views this company name. We can tell because date is listed as an object, D type or data type. Object, that just means it is text. There are a bunch of characters that don't mean anything. If we come down here, using that code before, we are referencing our pandas library, and we are saying to_date_time. This file that I've created that we've been using above, and by the way, I used ADM, you call it whatever you want, but I just did ADM because it is Apple, Disney, and Microsoft, but that has nothing to do with anything in terms of what your code should look like. Call the file whatever you'd like it to be. But what I'm doing here is I'm saying, in this file, make a variable called date, set it equal to this file, this column called date, but then apply this pd.toDateTime to it. So really what we're just doing here is overwriting the column date with a new column named date, and we are making it a datetime variable. So if I run this with info, you can see it's all the same, with the exception of now this is a datetime variable instead of an object. And this just allows us to use some better functions in Python than if it were just viewed as a column. And we're going to actually look at one of those here shortly when we do some things by year. Okay, so some more practice from what we did last time, except that we're going to add something. So we've already calculated price, right? We know how to do this. Our file, we're going to make a new variable, call it lag price, and it's going to be equal to that file. And again, remember last time we talked about why we do a group by. we need to calculate a lag price, but where Apple ends and Disney begins, that first observation of Disney, if all we're doing is lagging price, then the last price for Apple will be the lagged first price for Disney. And if we go down, it'll be the same case between Disney and Microsoft, where really what we want is the first observation of Apple should have no lagged price. The first observation of Disney should have no lagged price, and the first observation of Microsoft should have no lagged price. In order to accomplish that, we simply remember, say, group by. So do whatever we're telling our code to do, but do it by company. So do it for the first company, then start over and do it again for the second company. Do not continue all the way down the data set. You need to do this company by company. And what we're doing is we're saying, do something company by company. What is that something? It is take adjusted close and shift it one spot. In other words, take the price, move it down one. So now we have a new variable called lag price, which is the price that happened one period prior. We're then going to calculate returns the exact same way as last class, making a new file, and making a new variable, setting it equal to the current price minus the lagged price divided by the lagged price. So the new thing that we want to learn, and you apply this to any number of things, we want to drop missing observations. So last time we kept the first observation of Apple, the first observation of Disney, and the first observation of Microsoft. This time we're not going to do that. So let me just show you quickly what it looks like if I take that off and I do ADM and we print this. Here we go. Okay, the first observation of Apple is NaN. Remember, that's not a number. Okay, so here we go with our new data set. We've dropped the missing, and how we've dropped the missing is we've said take our file ADM. We're telling it to, we put the period there because we're going to reference some type of function. That function is going to be called dropNA. It is a basic function within Python. You do not even need one of these libraries like we were doing PD and things like that. So dropNA. If you want to, you don't put a subset, right? So you just leave it like this, and we'll talk about in place again. There's some review, but if you do this, it will drop all NAs, all missing values throughout every column. But the instructions here say, well, they don't say, I apologize, but what they should have said, and I'll actually change this right now, drop missing return observations. Let me save that. So we want to only drop those ones that are in the return column. So what we do is we say subset equals when we name the column or columns that we want. This says don't look for all missing values, only look for missing values in the return column. We did this last time, in place equals true. What it is saying is do this and rewrite the file. The alternative, if you do not have that, is you can manually rewrite the file by saying ADM equals ADM.drop. These are equivalent. You are manually overwriting it here. You're saying make a file called ADM and set it equal to a file called ADM where we've dropped returns. Alternatively, we can allow Python to do that by saying take this file that's already been created, ADM, drop missing returns, and do it in place. So there we have it. I do want to talk about one thing because how you write your code will make a difference. In this case, we've run the code and we've dropped returns. So what we have here is the first date is 2014-12/01. If we run this again, what's going to happen is we've already gotten rid of this first observation. So if we run this entire box again, it's going to overwrite lag price by putting this as lag price. There is going to be no first observation anymore. We are essentially going to rewrite it if you were to run this box again. which is fine. You then get your returns again. But what you'll notice is that we are going to have a new missing observation. It's going to be 2014-1201. This will be missing because we are overwriting all the variables. So if we run this with our remove, it will drop 2014-1201. And what's happening when we do this, right? Now this is our first file. There is no lagged price anymore. There is no adjusted price up here to make a lag here. So we are overwriting it. Remember that when you write your code. Remember to understand what's going on. If you didn't want this to happen, all you'd have to do is run the code once or make this in a new cell, a few different ways. But just be aware that every time I run it, it goes from month 2, sorry, I went down, to month 3, to month 4. And if that happens and you don't know what to do, it's pretty simple. Just come back up here to where you created this file. Here's where we created it. Rerun it. When we get down to here, we have our 180 observations back. And when we get here, we will be back to our original date. It will no longer be 2015-04-01. Okay, so that's how we go ahead and remove missing observations from that return file. And this actually makes sense. There should only be 3 missing observations. The first one for Disney, the first one for Apple, and the first one for Microsoft. We had 180 observations. You drop 3, you have 177. So next up is to calculate the standard deviation of stock returns for each stock over each year. So this is the first observation, or the first instance where we're actually going to benefit directly from having converted our dates to a date time rather than leaving them as just text or an object. Because this program now knows that these are dates, we can do a bunch of different things. What you need to do based on this is create a way to understand which years are the same, right? I'm asking you to create standard deviation for stock returns for each stock and each year. So in other words, I want to know what is the standard deviation of Apple for 2015, 2016, 2017, where within each of those years we should have 12 observations if the full year of data is there. Well, we need to be able to identify what those years are, and right now it's kind of buried in here within the date. So we're just going to do a simple way of getting at this, and we're going to create a new variable, call it year. Well, year is, as I just said, buried somewhere in this date, right, as that first component. So we're going to say, go to that date column, and we're going to access this with a .dt.year. So what this is saying is we're going to access this through a date function, and what we want it to do is identify year. We run it, we have a new variable called year, and if you look, all it did is extract the year from the date. And if we want to do, a few more, you can see that as that changes to 16, so does that. And just as a quick example, if we were to copy this code, paste it, and let's just make a new variable. We're not going to use it in here, but month, right? We have the opportunity to grab months. And you can see 12, 1, 2, 3, 4, 10, 11, 12, 1, 2, and so on. So this is one of the easy ways of getting dates, if you want to extract months and years and days and so on, and why we want to use our code up here to actually convert this to a date time to make things like this a little bit easier. Okay, next up we're going to do 2 new things. First one is utilizing group by. Second one is calculating standard deviations. Okay, so I'm going to make a whole new file, and the reason I'm making a new file is Python has a little bit of a hard time making a new variable where it's collapsing a bunch of variables. In other words, what I mean is we have 12 observations for 2016. We're going to collapse that into one number. It's going to be the standard deviation of the returns of those 12 months. If we were to try and immediately make that a new variable, Python has a hard time placing it in 12 different locations because it is going to be the same, right? Apple has 12 observations for 2016. It's going to have the exact same standard deviation in all 12 of those months because we're doing it by month, or I'm sorry, by year. Okay, so let's look at how we do it and what it looks like, and it hopefully will make a little bit more sense. I'm going to make a new file called std, standard deviation. I'm going to set it equal to this file that we're working at, ADM. I'm going to tell it to group by. Now the instructions ask for standard deviation for each stock each year. So we have done a group by where we did something by company. But just like when we concatenated multiple files instead of just two, you can also continue to group by multiple variables. In this case, we're going to group by company and year. What that's saying is it's going to identify all Apple, and then within Apple, it's going to identify every observation that has the same year. So it's going to view these observations as one, down to here, and then it's going to start again and do Apple for 2016, and then 17, and then so on. So what we're doing is telling it to group by each company year. Well, what are we doing once we group by it? We're saying go to the return column, right? Returns, and we say dot std open parenthesis, close parenthesis. It means calculate the standard deviation. I will talk about reset index here in a minute, so I'll show you what it looks like without it. Here we go. We get this weird looking thing where company is out here as an index, and then year as is an index, meaning this is how it's grouping. It's saying Apple, and then it's not repeating because there's only one Apple, and these are all the years within Apple. There's only one Disney, all the years within Disney, same with Microsoft. And the reason I'll tell you really quickly that 2014 is not a number is you actually need more than one observation to calculate standard deviation, and there is only 1 month of returns for 2014. So that is actually correct, don't worry about that. Now, if we say reset index, what this is going to do is instead of having these out here as these strange setup where there's only one company and then it knows internally that it's applying to all of these, we're going to make it retain that. So we have Apple 2014, Apple 15, Apple 16, 17, 18, and 19. Same with Disney. So I would just make this kind of a habit when you do multiple group bys, just to reset your index, especially in a case like this where you're trying to collapse a bunch of observations down. So there, we've calculated a measure of standard deviation or risk of returns each year for each company. If we look over here, merge the standard deviation file with the original file of stock returns. So unlike concatenating where we're just stacking two files, what we're doing here is we're going to merge them. We're going to put these files together instead of on top of each other, almost left to right, right? We're going to take this file and put it over here so there's more variables. How we're going to do that is we're going to have to find some variables in each file that are similar, and we're going to merge on those variables. In other words, we're going to say match Apple in 2015 across these two files. Well, up here we have Apple, so that matches year 2015. Well, here's those 12 of them. So in other words, we will expect 0.061226 to merge 12 different times. Now, before we get to that, notice that this is returns. These are the monthly returns. Right here, what we've done is we've taken this return file and calculated the standard deviation of it. but we aren't able to tell this code yet to rename it. It just knows that what it did is it did something to returns, but it has the same return variable name. So if we were to merge these together, this would have a problem because we already have a return file. What it would do is it would call one return X and one return Y. You don't have to worry about that right now because we're actually going to take care of it. We are going to change the name. Okay, we do not want this to be called return anymore. We want it to be called standard deviation. So how do we rename columns? Well, std is our file. We do period rename. And then in parentheses, we tell it what columns we want to rename. And here we have a bracket, or not a bracket. I don't actually know what this is called. A squiggly bracket. In parentheses, we have, or quotes, whatever you want, not parentheses and quotes, we have return, the file column that we want to change, the original name. We have a semicolon, and then we have the new name. So what this is telling it is go to the return column, replace the name with standard deviation. And if you want, you can go ahead and add a bunch of columns. It's not limited. It will rename multiple columns at one time. And as before, in place. So we're not going to manually overwrite this file. We're just going to let it do its thing. And there you go. We now have company year, standard deviation. Okay, so now we're on to merging. How are we going to merge these? So I'm actually going to add a little bit of code here and talk it through. These are not necessary. I'll talk about what that means. Okay, so we have our original file, ADM, and our new file, std. When I merge them together, I just made this to make the example simple, ADM underscore std. Well, how do we merge? We do pd.merge. Okay, we're going to get this from pandas, and we're going to merge. Left. Oops, I'm sorry, I should not say left on. I apologize. It should say left equals and right equals. Okay, so what we're doing is we are identifying two files, one which we are considering the left file, the left-hand side, one which we consider the right-hand side. If you want to write out this code, you can, but the first file you reference is always left, the second file you reference is always right. Okay, so without writing it, it knows this is left, this is right. And what we're doing is we are going to say, how are you merging these? By company and year. In other words, for every Apple 2015, I want 0.061226, remember? All of these should have the same standard deviation. So that is the on. You can do it on one variable, on two, on three, on five, however many you need to make sure that it merges correctly. How are we merging this? Well, this says left. Your options are left, right, inner, and outer. Left just means keep all observations in the left file. Right means keep all observations in the right file. Inner means keep all observations that occur in both files. And outer means keep all observations, period. Doesn't matter if they merge or not, keep them. So we're going to say keep all observations that occur in our original file, because this occurs in our original file, but it's not really a number. We just want to be able to look at all this. So if we run it, there you go. And since I gave the example of the beginning, oops, sorry. Well, there you go. I have an error. Sees what it does. Invalid syntax. I typed something wrong. I can come up here and identify where that is. I put the 25 in the wrong spot. So there we go. And so you can see, as the example I was talking through, standard deviation was merged to all Apple 2015 observations. That number we expected, 0.061226. And then it did all of the next year's observations. So there we go. We've now merged. These are really the only two ways you're going to combine files. You're going to concatenate and you're going to merge. So next we're going to learn how to filter. We filter stocks because we have errors. In this case, a negative return isn't an error, but there are going to be ways that we have errors in our data as we clean data. We think things shouldn't be there. So this is how you can go ahead and clean them. So the first thing I want to do is just describe the data. Look at the descriptive statistics. And I'm not interested in all of these descriptives. I just want to know what the return column looks like. So there are 177 returns. The average is 1.6%. The standard deviation is 6.5%. The minimum is negative 18%. Here's our different quartiles. Here's the median, and our max is 23%. The reason I really just wanted to do this is so we can compare. We now know there's negative values. So once we remove them, we're going to run describe again and make sure that our minimum is no longer a negative number. Okay, so the way we sort files, or not sort, I'm sorry, but the way that we keep or drop or filter our data is right here. I'm making a new file. I could have just overwritten it. I could have just dropped the observations from that original file, but I just wanted to make a new one so we have access to everything. So this is the ADM_STD, and I just enabled it _POS for positive. And what we are doing is we're taking our original file, this one right here with the negative returns, and we are saying .loc. What this is really trying to do is locate something. We're telling it to locate data. Okay, so what data are we trying to tell it to locate? Well, we need to go what file? Well, we're going to say we're working with the same file. So locate data. What data? The column, oops, sorry. The column of returns. And we want it to be what? Greater than, less than, equal to. You can kind of tell it what you want. So what we're doing is telling it, locate the column returns in this file. So locate returns within our original file and find all observations that are greater than or equal to 0. In other words, find all observations that are not negative. Okay? Because if we find all observations that are 0 or positive, we are excluding all negative returns, which is what this step is looking for. So this new one, this new file that we're creating, is going to have all the return observations from our original file that are positive or 0. And as you can see, the minimum is now 0.156%. We've dropped our negative returns. So we can also make this a greater than or equal to 0. Oops, I'm sorry, this thing was. We can make this a less than. In other words, if we want to do negative returns, we want to know, are there any returns that are actually equal to 0? And we want to put a double equal sign. One equal sign means we are assigning a new variable or a new file, right? That's why we only use one here. We're saying this new file is equal to something else. When you put a double equal sign, you are saying find where this is true. So I don't know if there's actually any 0 returns. There's not. We can see if there's any. It's unlikely that we're going to find one, but yeah. So let's go back here. I will show you an example. Okay, so let's copy this return. It might not match it. It depends if there's rounding. Let's see. Yeah, it rounded. Okay, so I guess I can just do this to show you really quickly. It is called company. I believe that's the name of the title. Yep. And we have AAPL. Okay, AAPL. There are 59 observations of Apple. So that's how the equals works. And that's correct. There were 60 to begin with. We lost one while calculating returns. So we have that correct. So let's get back to our original code. There we go. All positive returns. filtering out stocks with negative returns, i.e. retain stocks with positive or zeros returns. And then we confirmed it. So we're through step 12 over here. We confirmed it with a simple describe. Now we're going to sort stocks by ticker and return, calculate average stock returns, not all descriptive stats, for each company, and output the results just to see them. And that's simple. You guys have already done this step. And again, this is just, last time we sorted by a single variable. It was date. This time I'm just showing you that you can sort by multiple variables, and you can do 2, 3, 4, 5 again. It doesn't matter. You just keep adding. So we have our positive return file. We're going to do dot sort underscore values, and in parentheses we put our options. Those options in this case are what variables we want to sort by. This will sort first by company and then by return. So Apple should show up first because A is the lowest letter. Disney should show up second, and Microsoft should show up third, and then it will sort them by returns. In place again, we want to overwrite it instead of doing it on its own, and just some more practice with our group by. In this case, we're going to have only one variable, so we're not going to be having multiple levels of that index as we did above where it was company and year. So we can just go ahead and run this. Now this is good. I don't think we've seen this yet. This little orange, peach colored, maybe pink. This is just telling us this is a warning. It is not an error. It's telling us some things might be changing in the future, or what you're doing is maybe not the way that the creator of this library thought it should be done. Or sometimes it's just telling you that things are going to be changing, or just some hint or tip that they want you to be aware of. In other words, if you get a pink box, don't worry about it. You do not need to worry that this is an error. But in short, what we have now is sorted values, which I guess I did not show you, but I will show you right now. ADM, STD, BOS. Oops, I have a capital S as is case sensitive. There you go. Apple. Return that you can see they keep getting higher. Here's from Microsoft. You can see they keep getting higher, and these dots just show that there's data in between. But then also what we see here is group by company return. So over our period, Apple, when only considering their positive returns, 7.3%, Disney 4.7%, and Microsoft 5.1%. So that is the assignment. I'd like you guys to just practice it, get more and more familiar working with the different Python syntax, the way we write code, the way we work with data. A lot of what you're going to do in this class, a lot of what you're going to do if you ever do coding later in life, or if you use it in other courses, is really a lot of the same steps. It's things that you just learn how to do, and then you just apply them to different things. Like here, yeah, you're going to just keep two columns, date and adjusted close, but when you have a large data set and you want to drop columns, you're just going to use different variables. You know, down here, you're creating new variables by shifting or creating lags. Here, you're creating new variables by transforming different variables. Yes, you have now practiced calculating returns, but if somebody says calculate another variable, it's the exact same steps. You just have to know what the formula is. In other words, the formula being new price minus old price divided by old. You need to know what that other formula is, but it's the same steps. Make your file, create the new variable, set it equal to the formula. Things you're going to do a lot of. You're going to be doing a lot of merging. So yeah, you know how to merge these two specific things, but it's no real different, right? You now know how to merge two files together. If you forget, you have this practice code, you can just return to it, say, oh yeah, these are the steps for merging. Maybe I don't remember all the details, or maybe there's some other options. So let me copy that. Let me paste it. Here we go. So last time we talked about Stack Overflow, and yes, Stack Overflow is awesome. The other great one, especially for pandas, your PD, is their official website is excellent. They have a great library resource. So this one goes to pandas. I might check this out too. Open it up. Here are all the different options. Again, we don't need all of these, but they're here. You can read through them. you know how to do a basic merge now. All you're going to need to do is maybe make a few minor changes depending on what your data looks like. So with that, this is the lecture for week 3. Continue on with data camp. I'll put a simple assignment up. It'll be your only Python/Jupyter Notebooks assignment prior to the final project. This will also be your only week where you have just 2 assignments due. In terms of normal assignments, you will have some stuff with the final project that you might have to work on with some data camp stuff, but this is the only week where you have the 2 separate actual just assignments to do. So with that, remember guys, if you have any questions, shoot me an email. I'm always available. We can talk, we can do Skype, we can just do it through email, we can do whatever works for you, and have a great week.